Okay, chapter 3.3, multiplying decimals. I think you're going to find this pretty easy. We just need to talk about kind of how it works and how to add the decimals back in after we get done multiplying. Okay, so let me show you just a sample. This is one that you could probably do in your head, but I'm going to show you kind of using the fraction equivalences. So this is 2/10 times 3/10. 0.2 is 2/10, and 0.3 is 3/10. So we could actually write that as fractions, 2/10 times 3/10. And we would get 6/100ths. Okay, and 6/100ths, right away you could turn that into a decimal. 6/100ths is easily turned into a decimal. The book wants you to understand that 6/100ths is the same as 6 over 10 to the second power. 100 is 10 to the second power, so 6 over 10 to the second power. And they want you to understand that when it's a fraction, this 10 to the second power tells you that you're 2 places over in your decimals. So if we were to add 2 places after the decimals and put our 6 in and then fill in the 0, where 2 places is what that 100 or 10 to the second power tells us. Sometimes we just count zeros. We know that there are two decimal places here because there's 2 zeros. But they're smart to think about it as powers of 10, decimal powers of 10. 6 over 100 or 6 over 10 to the second power gives us 6/100ths as an answer. So 2 times 3 equals 6/100ths, and that looks like this. Okay, so that's simple. That's easy. Now just standard multiplication is what's next. We've got something like 4.8 times 7.2, and that's 4 and 8/10 times 7 and 2/10. Okay, now what I want you to notice is that you have 1 decimal place in this top one, and you have 1 decimal place in the second number. And so in our answer, we can add up our decimal places, and that equals 2 decimal places. And that's what we just want to keep track of. We can actually ignore the decimal when we're multiplying, and then when we get to the end, we can put it in at that time. When you're adding decimals, say you are adding 3.047 and you're adding to it like 39.6, you don't line up your numbers. Okay, you line up your decimals so that our 1s are in the 1s place, and our 10s are in the 10s place, and our tenths are all together in the tenths place. Now here we don't have any hundredths. We could add a 0 if we wanted to. We don't have any thousandths. We could add a 0 if we want to. What's important though is that we line up the decimals when we're adding. But when we're multiplying, we're just going to multiply, and we're not going to worry about the decimal at all until we get to the end. Okay, get to the end, we'll put it in then. 8 times 2 is 16. 2 times 4 is 8, plus 1 is 9. Okay, put a 0 here to hold our place, because now we're multiplying by something 10 times as big. The 1's place is 10 times as big as the 10th's place. So we've got to carry that over using a 0 as a placeholder. 7 times 8 is 56. 7 times 4 is 28, plus the 5 is 33. Okay, now I just add straight down here. 6, 9 plus 6 is 15, 4, 3. Now if I didn't make any mistakes, then this is my answer, 3, 4, 5, 6, and I remember I have 2 decimal places here, so put the answer right here. Put the 34.56 or 34 and 56/100ths. And if I just think about 4.8 is almost 5, and 7.2 is just over 7, so if we just did 5 times 7, we'd get 35, and our answer is close to 35, just under. So it's a reasonable answer. It's reasonable to expect, even if I just multiplied 4 times 7, I'd get 28. And 34 is quite a bit bigger, but we're at least in the ballpark. That's how that works. We're going to do one more real quick, and then a small example with a real world problem, and then we're done. Okay, so they've got 2.7 times 9 and 4 thousandths. So the thing about this is you can do it either way. I tend to like to put the bigger number on top, the one with more digits. Not necessarily the bigger number, but the one with more digits. So I'm going to write that one on top and multiply it by 2.7. Notice that my decimal points do not add up, but I've got 2 decimal points here, 1 decimal point here, so I'm going to end up with 3 decimal points in my answer. Okay? Now, 4 times 7 is 28. 7 times 0 plus 2 is 2. 7 times 9 is 63. Add my place value holder. 2 times 4 is 8. 2 times 0 is 0. And 2 times 9 is 18. Add everything up. 8. 8 plus 2 is 10. So I got to carry that 1. And I got 4. 14. Carry that 1. 2. Okay, and then I'm going to come over and put my decimal over here. I'm going to hold these 3 places out. It matches these 3 decimal places. And 9 times 2 is 18. 9 times 3 is 27. So my answer should be between 18 and 27 because 2.7 is close to 3. So 9 times 3 is 27. It should be smaller than 27 and bigger than 18, and I've got 24. So that works pretty well. Hopefully that made sense to you. Okay, now for the real world application. I'm going to switch over to the internet. We'll go back and forth. This is a picture from your book. Okay, you buy 2.75 pounds of tomatoes. Notice down here on the screen the tomatoes are $1.98 a pound. Okay, so they want you to find that they want to know how much change you get back from the cashier if you give them $10. Okay, so our 3 points of information are $2.75 a pound. Let's write that down. So tomatoes are $2.79 a pound per LBS. That doesn't work. Just write per pound. You guys understand LBs, I know, but we'll do it that way anyway. Alright, back to the internet. 275, not, and 189. Okay, 275 per pound. Is it per pound, or did we get 275 pounds? Yeah, we got 2.75 pounds of tomatoes, and it's really $1.89 per pound. So I spent all this time worrying about that, and it wasn't even per pound. We're going to just go ahead and fix this up. There we go. Alright, so we get 2.75 pounds LBS of tomatoes. And they cost us $1.89 per pound, and we have $10 in cash. Okay, so each 1 pound costs $1.89. Okay, it's $1.89 per pound, but we got almost 3 pounds. So if this were $2 per pound and we got 3 pounds, then that would be about $6. Okay, and we give them $10 back, $10 cash, so we should get back, we'll get back about $4, just using some logic. Okay, 3 times 2 is $6. We give them 10, they'll give us back 4. Alright, so, but let's actually do the math to make sure we have it right. 2.75 times 1.89. Now this is where it takes some real work because we've got 3 digits here. We have to do 3 sets. Hopefully I left myself some room. 9 times 5 is 45. Let's change colors just so we don't get confused. 45. 9 times 7 is 63, plus 7 is 67. 9 times 2 is 18, plus 6 is 24. Okay, add a 0. 8 times 5. Let's change colors again. 8 times 5 is 40. 8 times 7 is 56. So that's 60. 8 times 2 is 16. So that's 22. This time I have to add 2 zeros. Okay, 1 times 5, this is a little easier. 1 times 7, 1 times 2. And now I have to add everything up. I got 5, 7, 9, 7, 8, 9, 10, 11. Carry the 1 there, and then 5. So 5, 1, 9, 7, 5. Let's see, I've got 1, 2, 3, 4. I've got 2 decimals plus 2 decimals equals 4 decimals. So it's really 5.1975. That's what the decimal comes out to be. But since we're talking dollars and cents, we have to round that a little bit. We can't use the 75. But the 7, so we're rounding to the nearest hundredth place. So what happens there? Well, the 9 becomes a 10. So it really becomes a 20. So we really have $5.20. So if we have $10 and we subtract $5.20, now this time we have to line up the decimals because we're using addition or subtraction. Alright, and this becomes 9. And so 10 take away 2 is 8. $4.80. Is $4.80 plus $5.20 equal to $10? Looks right. So we'll get $4.80 back. Does that make sense? Let's see if we look through here. They did it this way too. So they multiplied out, they got 4 decimal places, just like we did. They subtracted 520. See, they had to round. And then they subtracted, got 480. So we got exactly the same answer as them. You do the same thing right here for number 9, which is one of the on your owns that you'll have to do in class. Okay, very good. You can stop watching now, or you can stay and watch me doodle a little bit. Okay. Well, we bought all those. What did we buy? We bought tomatoes, and I know that it's kind of fun to throw tomatoes, so we'll draw a little picture. Yeah, it's maroon. Where's the brown? Mocha. Huh. All right. So we're going to draw a little picture of this guy, and he's grinning and showing all his teeth. And he's got his concentrating eyes on his little haircut up here. Ooh, he's really out of control. He forgot to comb his hair this morning. Yeah. And he's really getting ready to throw a big tomato. I don't know what that is. It just doesn't fit into the drawing. We like to draw these guys without any real bodies, just the stick figures. I think it works best. So he's got a big, ripe tomato right here in his hand. So it's red, and he's gonna throw it. And what's cool is it's gonna make it's gonna make this shape when it hits you. Okay, there you go. Have a nice day.